In this last video, I want to take a look at a couple of applications problems just to remember, okay, we have this thing called the power rule. It finds the derivative. What was it that the derivative tells us again? Because knowing what the derivative represents is a really important idea that I just don't want to lose sight of. So for this first example, I have an object that moves along the y-axis measured in feet. So that its position at times x, which is measured in seconds, is given by our function f of x equals x cubed minus 15x squared plus 72x. We're going to start by finding the instantaneous velocity function v here. And I need to remember, okay, I'm given a position function, how do I find the velocity? Remember that one of the interpretations of the derivative is a velocity function, so long as we're starting with a position function. So if I want to find the velocity function v, that's really just the derivative of this particular function. So here I would just take the derivative of each one of these terms. Derivative of x cubed, that's going to be 3x squared. Minus derivative of 15x squared, that's going to be minus 30x. And derivative of 72x, that's going to be plus 72. So there's my instantaneous velocity function v. Part B says find the velocity at 2 seconds and then at 5 seconds. So this is remember these are x values, right? It says x was measured in seconds. So if I want to find the velocity at 2 seconds, I'm going to take, in this case, x equals 2, and plug that into my derivative or my velocity function. So we can either think about that as v of 2, or you can think about that as f prime of 2 and plug that into your derivative. So here I've got 3 times 2 squared minus 30 times 2 plus 72. And let's see if I can do this in my head here. I've got 3 times 4 minus 60 plus 72. So I have 12 plus another 12. So I have 24, and again, we're talking about velocity here, so we should give our answer in a unit of velocity, so in this case, feet per second. If I wanted to find the velocity at 5 seconds, I would repeat this problem. I would just take 5 and plug that in for x again. Remember, and one thing I'll mention in case you do want to try that problem on your own, remember we're talking about velocity right here. Velocity can be negative. That's okay. If you have a negative velocity, that just means you're moving backwards or you're moving down. Really just means you're kind of going in reverse. You're going in the opposite direction. So it's okay for velocity to be negative. It does not mean that you've made a mistake. But I want to talk about this last one here. It says find the times when the velocity is 0. So essentially this is saying, hey, take your velocity function and set it equal to 0. Let's find when our velocity function is equal to 0. So I'm going to take my velocity function here. I've got 3x squared minus 30x plus 72. Set that whole function equal to 0. So I'm going to start. This function, it's got a lot of big numbers. I don't really want to deal with them. I know that all of them, though, are divisible by 3. I've got that constant multiple of 3, so I'm going to factor that out. That'll leave me with x squared minus 10x plus 24 is equal to 0. So now the 3 right here, this isn't really going to be an issue. If I wanted to, I could just divide both sides by 3. On the left hand side, the 3's would cancel, and on the right hand side, 0 divided by 3 is just 0. But you don't necessarily need to show that work. I just get a lot of questions about that. I just wanted to make sure we address it. I'm really looking at this piece right here. And again, you can factor this. You can use the quadratic formula, however you prefer to solve your quadratic equations. I think this factors awfully nicely. I'll bring the 3 down just because. I need two numbers that multiply to be 24 and add to be negative 10. Those would be negative 6 and negative 4. So here I've got x minus 6 times x minus 4 equals 0, and then I'll take each factor and set it equal to 0. So x minus 6 equals 0, and x minus 4 equals 0. Here I'll have x equals 6, and here I have x equals 4. Again, we want to talk about the times, so we want to make sure that we include a unit of time. Up here we said that x was measured in seconds, so I'm going to go ahead and say at 6 seconds and at 4 seconds. And this is kind of, we're going to be thinking about this a lot going forward. This is a really important idea. Finding the times at which the velocity is 0. Well, what's happening if the velocity is 0? We said earlier that you could have negative velocity. That was okay. So if you have a positive velocity, you're moving forward, you're moving in the positive direction. If you have a negative velocity, you're moving backwards, you're moving in the negative direction. If your velocity is equal to 0, in that case, you're actually not moving anywhere, right? You're just standing still. You're momentarily stationary. You're standing there. So in this case, our object is not moving forwards nor backwards at x equals 6 seconds and x equals 4 seconds. One last example I'd like to do for this section, just because you'll see a lot of these in the homework. They're very good questions to study. So here I have f of x equals x to the 4th minus 8x cubed plus 7. Part A says find f prime of x. Well, we can just use our power rule here. F prime of x is equal to 4x cubed minus 24x squared, and derivative of 7 right here, I know that's just going to be 0, so my constant term drops off. Part B says, okay, now that you have the derivative, find f prime of 1 and f prime of negative 2. So here, f prime of 1, I'm going to plug that into my derivative. I've got 4 times 1 to the 3rd power minus 24 times 1 squared, which is 4 minus 24. I should have negative 20. In this case, I don't have a unit, so we'll just leave our answer as negative 20. And we also want to know what's f prime of negative 2, so we'll take negative 2, f prime of negative 2, and plug that into our function. So 4 times negative 2 to the 3rd power minus 24 times negative 2 squared. So let's see, here I've got 4 times negative 8 minus 24 times 4. And then we'll multiply 4 times negative 8. There I've got negative 32. And 24 times 4, I've got minus 96 there. Negative 32 minus 96, I will have negative 128 there. So hopefully nothing too complicated. Again, we're just using the power rule and then remembering, okay, what kind of cool stuff can we do with the derivative that we talked about in the last section. Part C says write the equation of the tangent line at x equals negative 2. So here, this is a problem we looked at in the last section. The equation of the tangent line. Remember, I need two things. I need a point, so I need an x value and a y value. And I need a slope. I need those two things. So they always have to give you the x value here. They say x is negative 2. So my x value, that's negative 2. Which means I need to find a y value and I need to find a slope. You can do these in any order that you'd like. I'm going to go ahead and find my y value first. And to find the y value, I'm going to take x equals negative 2. And I'm going to plug that into my original function right here. I'm going to take negative 2 and plug that into f of x. So f of negative 2 is equal to negative 2 to the 4th power minus 8 times negative 2 to the 3rd plus 7. So let's see here. Negative 2 to the 4th, I should have a positive 16 minus 8 times, this will be a negative 8 plus 7, so I have 16 plus 64 plus 7 should give me 87 right here. So that is my y value. So that is my y value, 87. The slope of the tangent line, well, the slope of the tangent line, shoot, that's just given by the derivative, f prime. And we would just take -2 and plug that into our function. Well, hey, we did that up here. We ended up with -128. So no need to go and do all that work again. I know that f prime of -2 is -128. So I've got my x value, I've got my y value, I've got my slope. I think we're ready to write the equation of this line. Y minus y1, and actually here, let's change up the color just so it's easier to see. Y minus y1, y minus 87 equals m, that's -128, times x minus my x coordinate, which is -2. And after that, we're taking this equation, we're solving it for y. So y minus 87 equals -128x. Remember here, minus a negative plus a positive, so I have 128 times 2, which gives me minus 256. Adding 87 to both sides, I've got y equals -128x. And let me do this in my calculator because I don't trust myself to make a math mistake. Minus 169. So there is the equation of the tangent line in slope-intercept form. Y equals -128x minus 169. So most of this stuff we've kind of seen before. Part D, though, this is kind of a new one, so I want to make sure that we talk about this. It says find the values of x where f has a horizontal tangent line. So a few things I think about here. First of all, let's think about what we know first. Tangent line. Well, what do I know about tangent line? Well, the slope of the tangent line, if I'm talking about slope of the tangent line, I'm talking about f prime of x. So, okay, I'm thinking about the derivative. Then I see this word horizontal. What do I know about a horizontal line? Well, if I was to go and sketch the graph of a horizontal line, right, and it can just be any old line. If I was to sketch a graph of this, what's the slope of that line? Well, this is the very first thing we talked about in this section. We said the slope of a horizontal line, that's just 0. So, okay, I want to find the values of x where we have a horizontal tangent line, so where the slope of the tangent line is equal to 0. So in other words, hey, where is the derivative equal to 0? This is the equation I want to set up and solve. So f prime of x, I lost track of that. Where is it? 4x cubed minus 24x. So f prime of x, 4x cubed minus 24x. 24x squared? Yes. 24x squared is equal to 0. I'm going to solve this equation for x here. So here, let's see, I would factor out x squared. That leaves me with, and actually let's factor out 4x squared just to make our work a little bit easier. That'll leave us with x minus 6 is equal to 0. I can then take each factor, set it equal to 0, so 4x squared equals 0. X minus 6 equals 0. Divide by 4 here, I've got x squared equals 0. Take the square root, I still have x equals 0. On the right-hand side, we're just going to add 6, so I have add x equals 6. So that means at x equals 0 and at x equals 6, I have horizontal tangent lines. And these points are going to be tremendously important for us in a few chapters here. So actually, what do I have here? I have a quartic function, I believe, x to the 4th. So what my function probably looks like, it's a quartic function. Actually, what else can we say? It opens upward. So most likely what this looks like, oh, this one's tricky. Something like this. Think about a horizontal tangent line. I see this right here. And I'm starting to think about that already. What might be special about this area right here? Why might I care so much about that part of my graph? I'm not going to answer that question. I just want you to start thinking about it because these are questions we will want to answer later on in the course. Last thing that I just want to remind you of here is that f of x tells you the y value of the function at x. So f of x is always equal to your y value. Please, please, please remember that. And f prime of x tells you the slope of the tangent line of the function at x. So f prime of x will always tell you your slope of the tangent line to the function. We have both the original function and the derivative. It will be difficult to keep these two things straight now, especially when we're first starting off. So it's really, really important that we remember which function tells us which piece of information. So if you want the y value, you want the original function. If you want the slope of the tangent line, you want the derivative.